This is your turn number 4 in section 3.4 part B, equations and graphs of polynomial functions. We are given the graph of a polynomial function and we're going to write the equation of that function that matches the graph. The most important points to refer to on the graph are the x-intercepts. So we see right now there is an x-intercept at -4. We see that there's one at the value 1, and there's also one at 3. Now we're going to look at the multiplicity. We can see at this x-intercept, the graph hits the x-intercept and bounces, so I know the multiplicity is 2. At 1, the graph hits the x-intercept and goes through, so I know the multiplicity is 1. And similarly, at x equals 3, the graph hits the x-intercept and goes through, so the multiplicity is 1. Now what I'm going to do is write this information into an equation into factored form. So we're going to go y equals, we're going to take this x minus 4 and write it as a factor x plus 4. Because the multiplicity is 2, the exponent becomes 2. The factor would be x minus 1 here, so I'm going to write x minus 1. It's really to an exponent 1 because the multiplicity is 1. And x equals 3 would be a factor x minus 3. And again, the exponent is 1. What I don't know is how narrow or wide this function is, so I don't know what the a value is. I do know that a value for this would be negative because we're starting in quadrant 3 and ending in quadrant 4, but I don't know the actual numerical value. So that's what's left to find. So what we're going to do is we're going to choose a point on our graph to sub into our function. It doesn't really matter which one you use. A lot of people tend to use the y-intercept, but if you don't want to use that, you can use any value that's good on the graph, that's very clear, and that is a whole number. So I'm going to choose the point 0, -10. And this I'm going to sub in for my x and my y. And then I'm going to solve for the a value. So -10 equals a. I'm going to plug in 0 for the x and 0 again, subtract 1, 0, subtract 3. I'm going to get -10. I'm going to get 4 squared is 16, -1. I'm going to get -3. -10, I'm going to multiply this out, which would give me positive 48, but I still have that a. I'm going to divide by 48 to isolate the a. Then we're almost done. So a would be -10 divided by 48, which reduces to -5/24. So my final answer for this polynomial would be y equals -5/24, x plus 4 squared, which are my factors and my multiplicity. But now I found that numerical value, which describes specifically for that function.